Hi, I'm going to provide some more explanation about your course project, right? So regardless of the choice of your project, there will be some common steps. Now, the default choice of the project is modeling a love story with a system of differential equations. So if you do not want to do a default topic, then you can think of any other scenario that you will model with a system of differential equations. And basically, you will need to follow the same steps. So you will need to set up the model, you will need to find data, you will need to fit model parameters into data, and then you will need to do some careful, rigorous mathematical analysis. Well, in any case, so let me explain a little bit about the default project, right? So the default project, it is based on Rinaldi's paper about Laura and Petrarch. It is called Laura and Petrarch, an intriguing case of cyclical love dynamics, and it is available in the course library. So a part of your experience is reading an actual research paper. So please, if you want to do the default project, please read Rinaldi's paper. Actually, even if you want to do something else, it is still worth reading. So now, Rinaldi begins with this data set that comes from some previous studies, right? So he did not invent this. So this comes from a paper on history that had been published 1 or 2 years prior to Rinaldi's paper. So on the x-axis, or maybe this is the t-axis, so we have time, and on the y-axis, so if this is y, well, actually it is called e here, but later somehow he calls it p instead of e, so let me write p. So on the vertical axis, we have Petrarch's emotion as a function of time. Now, every data point here, so every data point, it represents one poem. So Petrarch is a poet. So he wrote a lot of little poems called canzons. So every point here is one poem, right? So and the value of the p here is sort of the it's somehow measures the strength of Petrarch's emotion towards his mistress Laura. Well, not mistress probably. Well, towards his love interest. Okay, so then what Rinaldi does next? So he suggests a model, a mathematical model for the relationship between Laura and Petrarch. So here there are three, so one independent variable, so which is t, just the time, and three dependent variables. So p is Petrarch's emotions, L, which is Laura's emotions, and Z, which is so-called Petrarch's poetic inspiration, whatever that means. So if you look at it carefully, you will see that this is a system of autonomous differential equations, because the right-hand side of the system does not feature t explicitly, right? So there is no t. So the derivatives of the unknown functions are expressed in terms of unknown functions themselves. So but the t does not appear here. Well, these alpha 1 variables, well, they're not variables. So alpha 1, alpha 2, alpha 3, and so on. These are so-called parameters of the model, right? So which means that what we need to do, we need to find to replace them with some numbers. And in order to replace them with some numbers, we kind of try to make sure that the model fits the data. Well, but you probably wonder what is the logic behind the model, right? So now, to understand, it has a perfect explanation. So you need to read the paper to understand it, right? So basically, a part of your experience in this course is to read that paper, to understand the logic behind Rinaldi's model, and to apply that logic to model a different love story. So in other words, so if you are going to model a different love story, it means that you will have different characters, and your characters will have different personalities, right? So this Rinaldi's model, it captures personalities of Laura and Petrarch, but you will probably want to capture, well, personalities of, I don't know, Jack and Rose on Titanic, whatever, Mulan's character, anything. So um, your own character, so from your own love story. So then Rinaldi explains. So after he sets up the general model, so he finds the following values. So by clever speculation, sorry, AL should be, AP should be negative. Yeah, correct. So because AL is Laura's appeal, so or good looks, and AP is Petrarch's appeal or good looks. So which is why AL is positive and AP is negative, because Petrarch is ugly and Laura is beautiful. Well, in any case, um, so after he specifies the values of the parameters, so he can solve the model on a computer. So it means that although the system of differential equations cannot be solved explicitly, but it can be solved approximately on a computer. And then by doing it, so he can plot Petrarch's emotion as a function of t. And then we see that it follows the data points pretty closely, which means that it is a good fit. That's the idea. Now, in your case, you will have to do it too, but there are some differences. So one thing is that Rinaldi's data come from previous research. So if you're going to do the same thing, so love story, then you will need to generate the data yourself. So something similar. So several time points, and for each time point, there will be emotions of the characters at that time point. If you are going to do another project, let's say, if you want to model the COVID-19 epidemics, right? So then you will download the data from the web. Then you need to come up with your own model. So, and basically, if you are going to model Rinaldi's, if you are going to model a love story, so you need to read Rinaldi's paper, understand the logic. You will see that Rinaldi's explanation has the notion of the so-called there is a certain function that stays here. So let me show here. So that there is a certain kind of part here, and there is a certain part here. So, well, actually, not that, not the entire thing. So just this and just this. So yeah, I don't want to spoil the pleasure of reading the paper. So these terms, they have some special meaning. So it is these terms that they capture personalities of the characters. So you will need to understand the logic, and you will need to somehow modify these terms so that they capture personalities of your characters rather than Laura and Petrarch. So if, say, you want to do something else, let's say if you want to model the spread of COVID-19, then instead of Rinaldi's model, you will read about SIR model, and then you can modify the SIR model in, well, to sort of capture the spread of COVID-19 better. Then you must understand that Rinaldi's main objective was to publish a paper. So your main objective is to learn differential equations. So which is why so he feed the model into data by clever speculation, because he wanted to make a point. So he wanted to explain that, look, it is possible to model a love story with the system differential equations, and you don't even have to try very hard to feed the model parameters into data. But your goal is learning, and one of the things that you need to learn is this optimization by particle swarm. Well, yeah, fitting model into data by the so-called particle swarm optimization, or maybe a similar algorithm. Then Rinaldi's purpose is to show that that there are so-called limit cycles, that Petrarch's emotion evolves in cycles, and he wants to study the following questions. So he wants to figure out how much you can change the model parameters so that the cyclic behavior still persists. So you do not need to do that. And it is very likely that if you try to read these pages of Rinaldi's paper, you will not understand, because it is based on some pretty advanced mathematics. So instead, what you need to do, you will need to uh, find critical points of your model, and you need to analyze stability of critical points and make some conclusions about the underlying real life scenario. So something else, right? And please remember that, again, your objective is to learn differential equations. So your objective is not to, I don't know, feed the model very well into data. So if your model does not feed the data very well, it is okay. So as long as your model has a reasonable explanation, and as long as you demonstrate that you know how to feed the model into data by particle swarm optimization, it is good enough.